Good morning. This video we'll be discussing about the network layer protocols. So already we have studied this particular layer, or we have learned what does this layer is used and why we go for this layer. What are the different functionalities that are used, that we can able to perform using this network layer, that we have studied in OSI layer, OSI model, TCP/IP model and all. And here in this tutorial we'll be discussing about in detail about what are the protocols that are used in this network layer. So there are two primary purposes of the network layer. Or the first one, it is going to divide segments into network packets, and then this packets will be reassembled at the other end. So the first one is divide it and reassemble it at the other end. The other functionality is it is going to route the packets across the physical network, and it is going to find out which is the shortest path or the optimal path in order to route the packets from the source to the destination addresses. And in order to route this data, it is going to use the logical network address to route the packets. So these are the two main purposes of the network layer. So everything has to do with the inter-network connections happens at the network layer, like setting up data packet routes, checking whether a server on another network is up or it is running, or whatever, the addressing, the receiving of IP packets from other networks are all part of this. So as most of the internet data is sent through IP, this final step is likely the most crucial among the other layers. So now we'll be next comes the next comes the next slide. Yes. So in this slide we'll be discussing about the functionalities of the network layer. So what are the different functionalities that can be performed by the network layer? So network layer, so like host to host data delivery, logical addressing, routing and forwarding, fragmentation and congestion control. So the first is your host to host data delivery. So the network layer is responsible for delivering data packets from source to destination. So it is going to provide the service that ensures that packets will reach its intended destination or not. That is what host to host data delivery is. So you are delivering data packets from source to destination, and it has to ensure that whether the packet has reached the intended recipient or the intended destination, whether we have sent to the proper destination or not. So that is one of the functionality of a network layer. Next is your logical addressing or the IP addressing. The network layer defines an addressing scheme to uniquely address each and every like device. Even you in your laptops you could see an addressing which is a logical address, because it is going to change, and your physical address is the one is nothing but your MAC address. So it is, in order to uniquely identify each device on the network, we have this logical addressing. So the network layer, it is going to place the IP addresses of the sender and the receiver in the header. Whenever we send a data, we will be sending the IP addresses of the sender as well as the receiver in the header, and we also send the data part. So that combines the entire packet. So these addresses is going to distinguish each and every device uniquely and universally. So the header is going to contain the network ID and the host ID of the network, which describes which device of the given network is the receiver. So next is your routing and forwarding. So routing means it is going to decide which route from source to destination is the most appropriate. So it is going to choose the shortest route between the sender and receiver in order to forward the data packet. There are so many widely used routing protocols like distance vector routing, link state routing, and like path vector routing. So many routing protocols that are there. According to the application, we will be using it. So next functionality is your fragmentation. So fragment is nothing but splitting. Like the network layer is going to fragment extensive data in fragments to forward from source to destination, because it is done because each receiving node has only some set of the fixed capacity to accept data. Next comes the congestion control. So whenever like congestion control, so like whenever you are moving in a road in a lane, like so many vehicles gets accumulated, so there will be a traffic. Like the same way, whenever we send data, the data gets flooded into the network in tremendous amounts, and the router is like it gets into trouble to route them, or it is unable to route them properly. It causes aggregation of data packets into the network, which is called as the congestion. So whenever data packets are flooded into the network in huge amount, and the router is unable to route them properly, so that so much of data packets gets aggregated into the network, that is known as congestion. So the network layer is also responsible for controlling the congestion in the network. It's like it needs to check whether a fixed amount of data has been sent, whether the whatever data has been sent is properly received. Everything can be able to need to be checked by the network layer. Okay, and the next comes the services of the network layer are the guaranteed delivery, packet delivery within the bounded delay, security, and in order packets. So what is this? Like the services that are provided by the network layer are, so the network layer provides a service that it is going to ensure the packet will whether it reaches its intended destination or not, and packet delivery within the bounded delay. So that means this service ensures that the packet arrives within a defined host to host delay limit within the bounded delay, whether the packet has been received or not. Next comes the security. When we talk about security, there will be a type of key, like kind of key between the source and destination. So the network layer is going to use a session key between the source and destination in order to provide the security. So the payloads of datagrams delivered to the destination hosts are encrypted by the network layer, and the payload is at the receiving end, the payload is then decrypted by the network layer on the receiving end, and it also checks for the integrity and source authentication. Everything is all these services are maintained by the network layer. Finally, we have in order packets. In order means it is going to arrange it in a proper manner. Like I am sending hello means it is going to be received like OLLEH, something like that. Means it has to rearrange it properly, and it has to check whether all the data has been sent in the same like received in the same sequence as they are sent. So that's all about in order packets, and just a short description about the network layer protocols. We have ARP, ICMP, IPv4, IPv6, and IGMP. Just a short description about these 5 protocols. So ARP, it is nothing but address resolution protocol. It is going to convert a logical address, or you can call it as an IP address, to your physical address, that is your MAC address. So whenever a host on its network want to know what is the physical address of another host on the network, it is going to send an ARP query packet with the IP address and MAC address of the source host, and IP address of the destination host will be broadcasted over the network. So the ARP packet is received and processed by every host on the network, but only the intended recipient, the particular recipient, is going to recognize its own IP address in the request address and response it with the physical address. So that's all about ARP, and we also have a reverse address resolution protocol, in which the host knows the remote host MAC address but needs to know the IP address in order to interact with it. And ICMP stands for Internet Control Message Protocol. So whenever there is a network error or a network whenever we need to diagnose the network, there is some kind of protocol which is used in these days. In those days also. So network diagnostic and error reporting protocol. So ICMP is a network diagnostic and error reporting protocol. When the error has occurred, where like some kind of error we need to if there is a problem in the network, we can use whenever this particular protocol is used, we can able to identify why the error has occurred and because of which device, everything we can able to identify. So ICMP is a protocol that is part of your IP protocol suite, which employs IP as a carrier protocol, because this ICMP packet is enclosed in an IP packet. So we'll be enclosing this ICMP packet in an IP packet after it gets constructed. So it is an best effort non-reliable protocol, same as your IP. And we have we can also find out why the time has exceeded, or why the network is routed, why it is redirected. Everything we can able to identify by means of this ICMP protocol. Next comes the IPv4. Internet Protocol version 4 is a network layer protocol that addresses and controls information and it is also used to transport packets in a network. And in order to transport the data packets, as we have studied in TCP/IP protocol, this IP and TCP going to work together. And in case of this IPv4, each host is given a 32-bit IP address consisting of network and host ID. The host number, it's nothing but defines the host on the network, and your network ID is nothing but in order to identify which network it belongs to. And we have different types of IPv4 like classful, classless, and all. In class 4 we have class A, class B, class C, class D, and all. And next comes the IPv6. It's the latest version of the Internet Protocol version 6, and it containing addressing and control information similar to IPv4. So because of the exhaustion of IPv4, they have created this IPv6 addressing, so that we have, because even in your home itself you could see, like initially, like before 20 years and all, we have only one computers. Nowadays each and like one device, we can say. Now in the current era, like we have in each home, each and every person is having a mobile. Like more levels of addressing is required, or we can say like more number of devices are connected to the internet. So that 32-bit addressing is not possible. So that's why there is a need for raising the IP address size from 32-bit to 128-bit. That's why we have our IPv6 addressing, and we have a mobile IPv6 and all. So many are there. Like next is your IGMP. IGMP stands for Internet Group Message Protocol. IGMP stands for Internet Group Message Protocol. Then whenever there is a multicasting communication in the sense like a group communications required, right? In that case we go for this IGMP protocol. So that the resources will be used efficiently, and in order to broadcast message or data packets, and hosts and nearby routers use it for multicasting communication within the IP network. So IGMP we can utilize in streaming media, games, video conference tools, because multicast communication we can have multiple senders and receivers. So finally, what we can conclude is network layer is responsible for how a machine in a network can communicate with a machine in a different network. And we also we have seen different layer protocols like IPv4, IPv6, ICMP, etc. in order to transfer data to the destination. And the main two purposes of the network layer is dividing the segments into network packets and then reassemble at the other end. Another is to route packets across the physical network, and by choosing the optimal path. And we have almost discussed 5 different protocols, and the main functionalities are host-to-host delivery, logical addressing, routing, fragmentation, and congestion control. Thank you.